Hey guys, this is Coach Kaufman, and we are going to be working on the Unit 1-5 notes, vertical and angle bisectors. Okay, these are the notes, and you should have copied them down or printed them out during async time today. We're just going to go through them together. So this is a review from last time. It was in 1-4, but I just want to go over it one more time. And we are just talking about naming these angles in 3 different ways. So you can name it with 3 letters. You would write your angle symbol. The vertex must always be, must always be the middle letter. Okay, so you can name it always with B in the middle. You can name it ABC or CBA. Either one is fine. You can also name it with 1 letter, because if you call it angle B, there's no issue in understanding that it is this angle over here. If this line extended and angle B could be over here or over here, you would have to use 3 letters. But you don't in this case. Right, and then you need some sort of straight edge, which I actually have this little card that has my name on it. And I am going to draw an X with a straight edge. And these are going to be my angles that we're talking about using vertical angles. So vertical angles, I just think about it like this. You always have intersecting lines, and then it's the opposite angles on intersecting lines. So angles 1 and 2 would be vertical angles. They cannot be adjacent, so they cannot be next to each other. And they have to be opposite using 2 intersecting lines. So it has to look just like that. Alright, for angle bisectors, it is a ray that cuts an angle in half. So a ray that cuts an angle in half. So I'm going to start by drawing an angle. Your angle can look however you want it to. I'm going to draw mine like that. If you'd like to draw a more acute angle, that's fine as well. But I'm just going to make sure I have ample amounts of room. And so an angle that cuts in half. So if it cuts in half, the 2 halves are congruent, and I'm just going to use a congruent symbol. Now that's very important for what we're talking about today. So these 2 halves are going to be congruent. And the way I show that are these arc marks, and we're going to talk about that in the next one. You can kind of see in this. What are arc marks? Well, they show that 2 angles are congruent. So this just kind of gives you an idea of what the heck is going on up here. So maybe this is 47 degrees. This one's also 47 degrees. Okay. Cool. It's not necessarily drawn to scale, but we're going to go with it. And I'm going to write a written definition for this quick. So if you're struggling understanding with the picture, here's the written out words for the definition of vertical angles, and you can write that down if you need to. We're just talking more about vertical angles. We have angle 1 and 3 are vertical angles. Ooh, and check it out, they're also congruent. So vertical angles, very important, are congruent. So both things we're working with today are congruent. The 2 angles formed using an angle bisector are congruent, and so are vertical angles. So that helps us with what we're doing today. So angle 1 and 3 are congruent, angle 2 and 4 are congruent. All right, so two things that are congruent or equal, if they are the same, you would put an equal sign in between them when you're trying to solve. So we have 63 and we have 4x plus 3. And we want to solve for x. So we're going to subtract 3, 60 equals 4x. Okay, I'm going to go ahead and draw a line with that equals sign. And divide by 4 on both sides. So x becomes 15. And that's all it is. So you set them equal. Anytime you have vertical angles, you set equal and solve. And I'm going to give you a chance to do this one on your own. So if you'll pause the video and work it out, and then see the answer. So x is going to equal 10 on here, and I'll write it again. X equals 10. So all you're doing is setting equal and solving. All right, we're moving on. All right, this is important. This is from last time. The word supplementary and linear pairs. So we have to decide what the difference is between these two angles. So for angle A, angle B, and angle C, if we look at angle A, we've got to remember vertical angles are non-adjacent angles formed by two intersecting lines. These are adjacent. These are next to each other. So if they are next to each other, which means adjacent, there we go. They cannot be vertical angles. So these are actually linear pairs. So angle A and 36 are linear pairs. So they are going to add to equal 180. So if you take 180 and subtract 36 from it, then you will get 144. And that's how much angle A is. Okay? Great. B. Now B is formed by intersecting lines, and they are not touching, right? They are across from each other. The sides of their angles do not touch. So these are actually going to be congruent because they are the same. And you can also look, we've got a little tiny angle and then a big angle. So A could not be the same as 36 because you can't have a giant angle that's only 36 degrees. All right, and then for this one, these two are touching again, and they are formed by a straight line. This is the straight line, and they are adjacent. So you have to realize that they are linear pairs and subtract to realize that they are 87 degrees. So when you add these two numbers together, 87 and 93, they equal 180 because linear pairs are supplementary. All right? Moving right along. We've got this word bisects. And for bisects, anytime you see the word bisects, I want you to think this. Cuts in half. So two things that cut in half are then, that are cut in half, are going to be equal to each other. So if this is cut in half, that means that those two are the exact same. So we're going to set this up just like we set up vertical angles and set them equal and then solve. So minus 1, 32 equals 4x. And then we are going to divide by 4. Divide by 4. 8. So I've got my handy dandy eraser. X is going to equal 8. Okay. Moving on. So example 4. Actually, one thing I but before we move on, I would like to point out what happens if you plug 8 in right here. So let's say it wants us to solve for angle BAD, angle bad, and we plug 8 in. So 4 times 8 plus 1. So 4 times 8 is 32, plus 1 is 33. Well, check that out. It's the exact same, right? So this is just a way you can check your answer if you are unsure if you have done it correctly. If you plug your answer back in, it will be the same as that because we set them equal to begin with. Move on to number 4. We've got x plus 40 PRQ and 3x minus 20. Make sure it's just a lot easier if you can label something and see it. We're going to set these equal. So I'm going to start by subtracting x on each side. I'm going to bring 40 down. Don't forget my equal sign. This becomes 2x minus 20. A lot of times I see if people subtract x, they just bring 3 down. But just remember that this is like having 1x. So if you have 3 x's and you take one of those x's away, you have 2 x's left. So I'm going to add 20. Add 20. 60 equals 2x. Divide by 2. And x equals 30. And that is it for the regular examples. If you want a challenge or are in advanced geometry, then stick around. Okay, it talks about AB is the angle bisector of CAD. Solve for the missing variable. We're going to set equal 2 times 3x minus 4. We're going to distribute x plus 7 equals 6x minus 8. Okay, and I'm going to subtract x on both sides and then add 8. And so I'm going to get 15 equals 5x. When I divide by 5 on both sides, I will get x equals 3. Alright, using what you know about vertical angles and linear pairs, solve for x and y. So you can always set these equal using the vertical angle property and solve using systems of equations, but I think that's a really difficult way to do it. I think the easier way would just simply be, okay, we know that both of these are going to add up to 180 because they are linear pairs. So if they add to 180, we've got 3x plus 5 plus x plus 15 equals 180. And you can simply combine like terms. 4x plus 20 equals 180. Subtract 20. 4x equals 160. And x will be 40. Great. We know that x is 40. So then we can solve for these right here. 40 plus 15 is going to be 55 degrees. And then 3 times 40 is 120. So this one's 125. So this simplifies a lot once this happens. And all we really have to do is set these equal using the vertical angle property. So 55 degrees is going to equal y plus 20. Alright, I really didn't have to write the degree mark, but that's okay. So minus 20, minus 20. You're going to get 35 for y. So you have x is 40, y is 35. Let's just real quick make sure that we solved correctly by trying this one, 4y minus 15 equals 125, and see if we get that same answer. So we're going to add 15, 4y equals 140, and then divide by 4, divide by 4. I should have put y's. I always mix the x and y's. Y is going to be 35. Cool. Now we know what x is, we know what y is, we have to find the value of each angle, but the beauty of this is the value of this angle is going to be the same as its vertical angle on the opposite side, and same thing for this one. So if we're writing all of these angles out, we've got angle AED, angle DEB, angle CEB, and angle AEC. So notice all of the middle letters are E, because that is the central vertex. So this first angle, AED, is 125 degrees. The second angle, DEB, angle DEB, is 55 degrees. The third angle, CEB, is 125. And the fourth angle, AEC, is 55. And that's the pattern that will always happen. Oops, let me scoot that up so you can see it. That's the pattern that will always happen with these intersecting lines. The opposite will always be the same, and the adjacent ones will add up to 180. Alright, that's all I got for you. Bye, guys.